Welcome back, and in this video I want to help you understand how the chain of trust works within DNSSEC. Now we've got a lot to cover, so let's jump in and get started straight away. I want to first talk about DS records, known as delegated signer records, because this is how DNSSEC creates a chain of trust between parent and child. On the right we have the ICANN.org zone, the one that we finished with in the previous video. It contains the public key signing key for that zone and some other DNS stuff. Now I'm not devaluing the other DNS stuff, but because of the hierarchical architecture of DNS, we don't have to think about it at this level. All that matters when we move up a level are the ICANN.org name servers for normal DNS and the public key signing key for DNSSEC. On the left of the screen we have the parent zone for ICANN.org, which is the org top level domain zone. This is one level up in the DNS hierarchy. In this part of the video I want to focus on how the .org zone delegates to the ICANN.org zone for ICANN.org and how DNSSEC delegates trust via the trust chain to this child zone. Now because DNSSEC builds on top of DNS, we start with the delegation for DNS. This is in the form of name server resource records which point at the name servers hosting the ICANN.org zone. This just integrates the ICANN.org domain into the DNS infrastructure. It doesn't provide any of the verification which we're looking for from DNSSEC. Now there's a matching RRSIG for this RRSet which verifies these records, but for the parent to child zone trust we need more. The .org zone needs to explicitly state that it trusts the ICANN.org child zone, and this is done using a delegated signer record set. And what this does is store a hash of the child domain's public key signing key in this record in the parent zone. Since the hash is one way and since they're unique, adding this record shows that the parent zone trusts the child's key signing key for that child zone. So at this point the .org zone is confirming its trust of the ICANN.org KSK via this record set. And like everything else relating to DNSSEC, we need to provide a mechanism to validate this DS record set. This means a matching RRSIG, which is a digital signature of the DS RR set, made using the .org zone's private zone signing key. At this point, all of the records can be validated within .org and we can confirm the trust of ICANN.org. Now we just need to add the records which store the .org zone's public keys. So this means a DNS key record set containing the .org public zone signing and key signing keys, and these are used to validate RRSIGs in this zone. And this DNS key RR set needs a matching RRSIG, which is created by signing the DNS key RR set with the zone's key signing key. At this point, if you trust the .org zone's public key signing key, then you trust everything in the .org zone, including the trust delegation to the ICANN.org child zone. And how do we trust this? In the same way that the child ICANN.org zone was trusted by the .org zone. Trust is given from the parent zone, which in this case is the root zone. This is the process how a parent zone trusts a child via the DS record set, which contains a hash of the child zone's key signing key. Now if we zoom out a little bit, I want to talk about the DNSSEC validation flow, so how we build this chain of trust between the different levels of the DNS hierarchy. So the trust between the levels from child to parent is created via public key signing keys and the DS record sets in the parent zone. So the ICANN.org zone, it has a public key signing key. The .org zone validates this by having a DS record and storing a hash of that key signing key in that record set. The .org zone has its own key signing key, And the .org zone is trusted because a hash of this key is stored in the corresponding DS record in the root zone. At the DNS root zone level, we hit a problem because there's no parent zone to provide this trust. The root zone has a public key signing key, and this and the corresponding private root key signing key, these are explicitly trusted. I'll talk about how this explicit trust works and what happens in the video dedicated to the key signing ceremony, but at this stage just take it as fact that the root key signing keys are trusted explicitly. They're known as a trust anchor, and every DNSSEC capable client or resolver by default trusts these keys because there's no parent zone to the root zone. This has to be a trust anchor, something that just is. So because we trust the root key signing keys, it means that a DNSSEC capable resolver can follow this chain from root through to the DNS record set. So the root zone key signing key has signed the root zone signing key. This has signed the .org DS record in the root zone, so this can now be cryptographically validated. This record matches the public key signing key in the org zone, and so this too can be cryptographically validated. Inside the org zone, the key signing key has signed the zone signing key, and this has signed record sets including the DS record set for ICANN.org inside the .org zone, and so this also can be validated. This contains a hash of the public key signing key for the ICANN.org zone, and so lastly this too can also be cryptographically validated. And this is how you build a chain of trust from root through to record sets. We start with the trust anchor that's created during the key signing ceremony that I'm going to be talking about in a separate video, and then at every level of the DNS hierarchy by using DS record sets, so delegated signers, we create a hash of the key signing key of the child domain, and this creates the trust from parent to child, and we follow that hierarchical trust all of the way down to the actual record sets. And this is how we can trust the contents of all of the TLDs. This is how the TLDs trust any domain zones, and this is how we can trust the contents of any record sets within those domain zones. And all of this can be cryptographically validated at every step, and this is one of the major benefits that DNSSEC provides. Now at this point, that's everything I wanted to talk about in this video. In the next video, I'm going to be detailing exactly how the key signing ceremony works and why this is such a critical event for the security of DNS using DNSSEC. But at this point, you can go ahead and complete this video, and when you're ready, I'll look forward to you joining me in the next.